It is my pleasure to introduce one of Nagios' finest. If I get a nice big round of applause for Spenser Reinhardt.
Thanks. Hello, everyone. How are we all today? Ready to get out of here and go put some stuff back into practice? Maybe. Well, hopefully I can give you something a little extra to go back home with. My talk's a little bit different than a lot of things you're going to see here, mainly because I'm using Nagios. Nagios is all over this, but it's not necessarily the focus of everything. So to get started off, I'm Spenser Reinhardt. I'm a member of our technical team. I'm the plugins security developer. And yeah, I do a lot of fun stuff with Docker, and I've been working with a bunch of our different projects and getting them into Docker containers and other things like that. So what are we going to talk about today? We're going to go through what Docker is, what a honeypot is, why you might find them useful and valuable, and where Nagios fits into all this. Hopefully we'll get some time to go through some cool screenshots. I can't give away too much information on my actual live production system of this because it's really, really easy to identify where it is and who I am. But I'll give you some faux stuff and you can at least see what it looks like or would look like in your environment. So, Docker basics. What is it and why do I care? Docker is like a chroot on steroids or a really light VM. The biggest thing it shares with your host OS is your kernel, which is a rather large sticking point in the security world, but it works fairly well. It's very, very near instant recovery of things that you've already set up. It allows file level backup and snapshotting very easily, and there's quite a bit of isolation, both network-wise and application-wise from your host OS. And it also allows you to restrict resources that are given to those containers. So where do you get started with Docker? Docker is all about Docker files. And you can see one on the right. The next slide has a little more detail on it. That's essentially what it looks like. Largely, I use Docker and integrate with GitHub because GitHub's great for storing your code. And GitHub and Bitbucket also happen to integrate with docker.com. And you can use it to automate your builds and give it, here's a folder path in my repository, or here's a branch with a Docker file in it. Go there, build my container every time I push to that branch or that entire repository, or you can wait until another container's been built and build off of that as well. And it's really nice because they let me abuse their system quite a bit for this. I'll push out probably 300-400 new containers in a day, and they don't complain. And that's with the free service, so it's awesome. So if you're looking at a Docker file, we're not going to go over this. There's not enough time. But just to put it in the slides so you have a pretty good resource, this is the important events with or configuration options. And you can see it really doesn't look that far off from shell scripting because that's essentially what it is. So how do they work together? Well, GitHub Docker links to my GitHub. There's a API hook that comes in. It registers with my user account, and my accounts are actually hooked together through a couple of different services that they both share. And what Docker does is tells GitHub, when he pushes to this branch, I want to get a notification so that I will go and re-pull and rebuild everything. And so as you're testing things, as you're trying to get new software to work, one of the things we're looking at internally is using this for a testing suite. It's actually what your Jumpstart lab, if anyone played with that, was run on. Entirely on Docker and Linux, except for one Windows box and some Cisco stuff. So here's what my repository for our presentation looks like. You can see it's got a bunch of different honeypot names. Well, you may not know that they're honeypots at the moment, but got some scripts, the standard README, nothing too special. It's kept up to date. It's actually taken from a repository on my personal account. But if we go to docker.com, this is what it looks like here. Pretty sort of the same. You can see you've got I've got tag names, which is how you differentiate different containers among also their repository within Docker land, and it's very much like Git, or JIT as some people prefer to call it. The key difference you might notice between some of these is going to be the, that's really hard to see, the development ones up top are all their own branch, and you can see the branch name over here, and then there's a master branch down here. So if I push to the master branch, it's actually going to build all of them except the development branches, because everything's in master. If I push to an individual development branch, it's only going to build that container. And it makes it really nice. I don't have to waste whatever limited resources I do have on Docker to deal with that. Moving on, honeypots. Not a thing that's talked about too often. The security industry largely seems to like their intrusion detection systems, firewalls, stuff like that. We focus a little less on actually putting something in our network to collect unknown things. And this is the approach that I take to honeypots. Internal to your environments, you probably don't have an IDS going through every major branching location or routing location, or you probably do have one between your DMZ and your production network. Well, that's great, but do you have anything actually identifying and looking at the traffic in between or on that network itself, and not just at the border devices? And honeypots kind of let you do some of that. Now, it's not purely a traffic analysis. They essentially provide a service, or in some cases a full OS or application, that are generally emulated because it allows for quick reversion to a working state. You might have shellcode emulation, you might do SQL injection emulation. Some of them are full SSH daemons that just love to mess with hackers, and it's great. Specifically, high interaction honeypots are full OS systems generally, or applications. You're going to run them either on a full hardware system or a virtual machine, and restoring it, repairing it, especially if it's a physical system and someone gets around whatever security defenses you had in place, not a fun time. Lower interaction honeypots, on the other hand, which is what we're using, are the ones that just emulate a service or an application or an OS. They run just like any other daemon on your system would. You can stop and start it, and essentially this is what we're putting in our Docker containers. The key with honeypots, though, as you can see by the bottom point, is almost all activity to them is suspicious activity. There should be very little, if any, valid traffic that ever goes to it. And the reason that is that you're putting this up not to provide service for anyone else. You're putting it up to see what's probing your network for services that aren't otherwise there. And so Honeynet Project is a fantastic group of people from all across the world that have put together quite a bunch of different solutions. Nepenthes and Dionaea are very similar to one another. Dionaea is, in fact, the successor to it, to Nepenthes. And essentially, they can do anything from Samba to SSH, web applications, you name it, they pretty well cover it. It's very much, I would call it the Nagios of honeypots, because it's so modular, you can just throw anything you want in there, and it really works with it quite well. We're not using Nepenthes in this case because Dionaea does almost, if not all, of the same emulation. There's really no need to go with the older version, even though it works perfectly fine. Glassdoff is a web application honeypot specifically. It's built to look for automated drive-by attacks for people that are looking to use your web server as a drive-by download malware provider, which is not a good thing for your company. Kippo is a little bit different. It's an SSH daemon, but it's different in that it provides almost a full shell to the attacker if they provide valid credentials. And once it does that, it may change ls commands to be cd commands. It may give you false readings and applications that are running. It does all sorts of things to just mess with the attacker and see how they deal with it. It's really interesting, some of the stuff I've got from running in different cloud environments, what these people, once they finally do get a password that works, when you set one relatively easy, what they actually try and do on your network. And when they finally realize that they can't do anything and that they're in a honeypot, what they do to try and destroy it and get out of it. Thug is a very different one from the rest of them. It is a client web browser, and it's exactly what you think. You give it a URL, you give it a phishing attempt, and it will go and act like a client machine, just like your salespeople that go and get infected, and your IT guys have to go deal with it. They go, and this emulates that browser's behavior. So you can collect the malware sample, see what your people may have actually gotten hit with. So when you're getting spear phishing attacks, this might be something that you'd give those URLs to so you can collect information on your attacker. Conpot, same general idea as the others in that it's just a daemon that runs, but it provides industrial control systems and SCADA emulation. So a lot of SNMP, web application, some other like Modbus protocol that you wouldn't normally see with other people. Honeybrid and Bitfrost aren't specifically honeypots themselves. Honeybrid in particular is an intelligent firewall that makes it easy to handle informing your Linux firewall how you want it to handle traffic as an attacker's interacting with you. I actually didn't choose to include this because it wasn't needed, and with Docker it really makes a mess of IP tables. Not their fault, just the way that they interact. So it's not in there, but it's an honorable mention because it does, initially in previous years, this is something I've been working on for 4 or 5 years now. This is something I was using that was extremely effective. Bitfrost, again, a little bit different. Generally, you'd use this with something like Kippo so that you can collect additional information on the SSH session, stuff that the daemon may discard or other things like that. So you've got a couple different options if you choose to deploy what I'm talking about today. The arguably most basic one would be to have the internet come into your firewall. You split off either known services that your devices use and give everything else to the honeypot, or you can specifically have everything go to the honeypot that you know is not destined for your actual production networks, whether you do that by purely port or IP or however. Personally, not my suggestion for what you do or how to implement it, because annoying attackers and putting this on the internet is not good for your business. So an alternative approach, which gives more benefits than just finding potential attackers, malware intrusions, things like that, is internal honeypots or honeynets, however you choose to word it. And the idea here is on the right side, you have your workstation environment. You've got your techs, your engineers, your whoever it may be. Someone gets infected, and you've got a honeypot there. Well, that person that gets infected, their malware starts scanning the network. We want to see what other devices we can hit with these same exploits. Well, it hits your honeypot. It shouldn't have done that because now you know it's there, and you can ideally go and look at that system and get it properly cleaned up before it can do much more harm. Same thought on the right side behind me with your, say, production web servers or your DMZ, something like that. You throw it internal to your network. It does not have internet access. But if something does get into your network, if someone's probing you through PHP requests, something like that, if you have a vulnerability there, ideally this will help you identify that in that when they touch it, which most people inevitably do, you know where they are currently at least, or within a very short time frame. One side aspect of this is my penetration tester friends that run into networks like this really don't like people that do this. Well, they really like them because they take their security seriously generally, but they really don't like finding these because it takes them tons of time to figure out that it's not a honeypot. And in a pen test, much like anything else, time is money. But as a person that's getting pen tested, it's a great example of, did your pen tester actually go and scan your network and find your device? And were your teams able to see their activity on your network? So aside from just intrusions and attackers, it does give you and provide additional benefit beyond that. So basically what I've got set up here within my virtual machine, I choose to deploy this as a virtual machine. I don't have enough physical servers. Some of you with real resources can do that. But essentially what Docker does for me is it creates, through Docker and through some networking setup and IP tables, all of these little items here are containers. So you've got each of your different honeypots running through the host IP tables. We'll discuss how that filters everything in a moment here. As everything comes through, a splice of everything goes off to Suricata so that an intrusion detection system can look at it and say, hey, is this actually important? It doesn't block anything. It's purely there to see what it sees. And it also gives you the ability to, if you choose to do this, work on further signature-based detection with stuff that your honeypots identified and your intrusion detection system did not. But essentially, information or an attacker comes through host system's network connection. IP tables routes it to whichever box it should be destined for. They do their interaction, and the MySQL and file storage there are actually not network connected. Docker allows you to do some things with what they call volumes, and effectively, it allows you to share files and share resources between containers, whether on a read-only or read-write basis. And so like the MySQL and file storage are long-term storage systems. When they shut down, they store everything. When the honeypot shut down, they actually wipe themselves and go back to a known good state. And that's intentional, because if they ever break, if someone blows them up and actually gets into the container environment and isn't in the daemon itself anymore, now you're going to get stuck at least there. Or when the honeypot daemon closes because your shellcode killed it, the container's going to restart anyways. And that's one of the beautiful things about Docker as well, is if your process exits, it kills the container. So it makes it much more difficult for an attacker to stay in your system when they send you bad shellcode, kill your process, and now it's not up anymore. On the Nagios side of things, we've got a couple things going on here. We have, again, it's still in the same system. I've actually run this both separate, where the containers are reporting back through just a standard Ethernet connection or virtual switch connection to actual other VMs. I've also got most of this containerized, so it does work as a single VM altogether, which is pretty sweet, but it does take a little bit of resources. But effectively, you've got XI there to check and make sure everything's running. If something's stopped, it goes and starts the container again. If it detects that there's an issue with your, well, in particular, NNA, for instance, looks at your traffic. And if it detects too high of a rate from one particular IP address, it will set off an event handler in XI through a service check that tells the IP tables to basically fail to ban that IP. And let's block it for an hour as my default settings at the moment. Log Server does effectively what you think it does. It collects all your logs. It lets me filter out important information through the Grok stuff, Grok filtering and regex stuff. You can actually take like the output of Dionaea that you'll see in a little bit that actually gives you shellcode and turn it into a binary shellcode if you want to. I wouldn't suggest it unless you know what you're doing, but it's kind of cool nonetheless. And then you can see they all talk through the network. You can see the Honeynet there on the right, well, left-hand side. IP tables. This was something that took me a long time to figure out how I wanted to do this right. And I think I finally got it to a point where as long as it's on a virtual machine, it's going to stay this way, and it works very well. Essentially what happens on your host OS is your traffic comes in and you hit the standard incoming rule or input rule. When it comes in, or when it does that, the first thing it does is look for rules that are tagged. And by tag, or the tagging is done through a module called recent. And recent allows me to say, hey, you've connected before. You've hit this IP address, or you've hit this port before. Well, what I'm doing is using those tagged rules to go to specific honeypot chains. And so I say if you've been tagged by going through the default set of rules in the green on the bottom, you've hit one type of honeypot already, you're going to keep hitting that one for a period of time until your connection stops and doesn't start for over 5 minutes. You're not going, and then you finally connect to a different port, you're not going to get a different honeypot. And the reason behind that is that it doesn't give away that your system is running all of these different services. If an attacker finds it, say they hit port 80 first, well, they're only going to have port 80 and 443 available. If they come back a half an hour later and they hit port 161, they're going to get Conpot, which is SCADA and ICS, and you'll have about 4 different ports, SNMP, Modbus, a couple other things. So it allows for flexible behavior on what you're doing. It allows you to add additional rules in a pretty straightforward way by just adding them to the input rule for fail-to-banning and stuff like that. And it allows you to really restrict what your attacker is actually seeing in the environment that they're going to get so that you can properly emulate it the way you expect it to have happen. So what's it look like on my system? Well, here's XI. It's pretty basic from an XI perspective. All I have it looking at is how long it's been since something attacked my systems, which is actually a passive check sent in from Log Server, and then how long, or whether the Docker container is running or not, and in performance data, it says how long it's been running as well. Nothing too terribly fancy. That's pretty much all I need to get out of XI what I want out of it, which is just to make sure everything's running. If it stops running, there's event handlers to make it start back up. Looking at Log Monitor, here's a pretty selective view of one of my live systems. And here you can see, hey, here's all of the Nagios results for Docker containers. Starting at the very bottom, I don't know if it's too readable. You can actually see responses from the log checks going into Nagios as well. Here's our NNA system. You can see the Honeynet is the second one from the bottom. Otherwise, we've got everything else monitored, including Nagios XI, Log Server, the firewall, your standard stuff. And this is actually, the firewall is a separate system that is for management incoming. But regardless, you can see the Honeynet host actually doesn't get that much traffic. Even in public cloud IP space, it's busy, but it's not too busy compared to some other stuff. Internal traffic seems to overtake it quite a bit. So what does XI do for me? It monitors my containers, make sure they're running, make sure the daemons within them are up and available. It has event handlers to handle whether they're not up and running, restart them, kill containers if it sees something is stagnant or taking too many resources, things like that. It also gives me a fairly active view of what's going on in the environment. I know whether stuff's working or not, whether it's received a connection lately, whether someone may be connected now to it, because you may have gotten an attempt recently and your recent attack counter could be basically 0. And it also, of course, notifies you. These are actually notifications I like to get because it means I get to have happy fun time with shellcode, which is someone that's a regular Def Con attendee. That's quite a treat for me most of the time. Network Analyzer, it's got a pretty simple job here. All it really does is let me do some geo-IP location. It collects the flows from all of our different devices and lets me say, oh, this attack was this many bytes, it came from this part of the world at this time, and helps me to kind of look at where the stuff is coming from, when different areas attack, things like that. On an internal network, it would still be useful in the sense that you could say, hey, I saw one attack into this particular honeypot, but I also saw a bunch of Iptables hits before that were passing through my host system, or my host system was seeing but dropping, and give you an idea of, well, really that system is quite a bit more active than that one honeypot saw. It also does trigger abusive and, say, oversized, if you will. So if someone tries to send me a couple gigs in a payload, I think I'll stop that. Log Server collects and stores all my logs. It does a great job. It really gives me, as I'm sure you've seen with Scott's talk and other people that have talked on it as well, it really gives you a lot of ability to look through your logs, actually filter out unimportant data. I think I take a little bit different approach than a lot of people in that I look to exclude known good things and only include bad things or not remove them. And the reason I do that is then on my honeypots, there's a lot of traffic from the Nagios system. As long as it's working, I don't care what it does. But I do care when something new comes into my honeypot. And if that gets out of my view because there are too many other logs, well, that's not going to work. So I use exclusion of known good things and known okay things to make it so that I only see the bad and what is unknown. And that really does help with going through all of this business. So hopefully we're going to get to some fun stuff here. I tried to do videos. Apparently I'm really bad at video editing, so you're going to get screenshots. Feel free to ask questions. If you have one, just raise your hand. Glassstaff, it's our web application honeypot. It only has 80 and 443, as you might expect. When I say it's an emulated PHP virtual environment, it's not just that it's a VM and in a Docker container. They actually have full emulation for the core way PHP handles functionality and implementation. It also has an emulated MySQL backend, so it can properly replicate SQL injection attacks and things of that nature. It makes for some very interesting stuff with web defacement bots and things like that. Oh, wrong button. There we go. And you can't read that at all, can you? Okay, that stinks. So what you should see here, and hopefully you'll see in the slides, and hopefully other ones are more clear, is that I am using SQL map to basically run a quick directory scan against the Glassstaff honeypot. And it's SQL map is not too happy about it because Glassstaff likes to change what it's sending attackers back so that they get different things. You hit a bunch of Google dorks and you end up getting a bunch of bots in when Google indexes you. So SQL map is not really happy about the page constantly changing even though it's requesting the same data. And what we can see oh, that's a little more clear. You can see some of the GET requests that it's doing, some things like that. You can actually see, looks like there's an issue with it connecting to honeypot feeds, which is a service that the honeypots talk to each other on. But specifically, you can see the GET requests there from my attacking system, which happens to be Kali Linux in that case, and just some requests that it was doing. Dionaea, the Samba, basically full, very similar to a Windows system if I were to peg it as something. But as you can see on the bottom, you've got all sorts of different ports by default. And it only expands if you get into what you can do with modules and plugins. FTP, TFTP, EMAP, Samba, MSSQL, MySQL, SIP, TFTP. I know just about everyone in the room's got at least 2 or 3 of those. It's really interesting to see on an internal network. I actually worked for a company that let me deploy this a couple years ago due to a configure issue. And it was really interesting to use Dionaea to actually track where the infection was in the particular isolated environments that we were working with. Slightly off topic, but Dionaea, much like Glassstaff does with PHP, it gives you a full environment to emulate shellcode. So if someone sends you a reverse bind TCP connection shellcode, it will actually reverse connect to them and properly emulate what they should be seeing. So, hey, kind of readable. In this case, this is Metasploit. I'm using the good old MS08067, down, add, up configure, just like I talked about. In this case, the exploit actually fails, which is fine. It fails because it's not using the right detection for OS, and it's decided that it wants to use Windows XP SP2, which is not right for Dionaea. I believe it needs to be SP1. Anyways, you can see, hopefully that's readable, kind of. This is the actual output from Dionaea in its log messages. It's essentially saying, hey, I got a new connection. Here's the shellcode I've received. Here's what they're trying to do. And it gives you a bunch of other metadata about the information that you've just received. Kippo. Here's our fun little guy that likes to mess with hackers. It's, like I said before, specifically an SSH honeypot. It does, by default, host on port 2222. You can use NAT or force it onto 22 if you choose. Doesn't really matter. It, unlike other things, actually provides a full or almost full shell for the attacker to play in. I think I mentioned that it may change commands around on them. It may give them the listing of a different directory. It may just remove commands on them at will. I believe it does everything based off a random engine in the background, and it really messes with them. It's funny to see how they respond to different things. But specifically, it does emulate an SSH daemon, so seeing some of the shell shock stuff that's come out recently, there's been a lot of people trying to use connection attempts with that or use bad crypto keys, things like that, to try and mess with it. Not too bad. Here we're just using Metasploit again to run a quick password attempt against the root account. It's got a password list that it goes through, and it just continues to attempt it. This also failed because none of the words in the dictionary match the password that I have set, which is kind of funny because it's a pretty basic password. The response to that, you can see one of the nice things about log servers, you can see me testing this attack against, so that I could get the actual slide for you. What you've got here is a bunch of the failed attempts from me trying to connect to it. In this particular filter that I have on here, it's not showing more of the details that Conpot can provide, like what the attacker actually did, what the username and password was, if they tried to actually exploit something or just get in through a user password match. But it's just kind of nice to see that, hey, even with the filter that I've got here, it still shows my previous data of me going, let's poke at that and make it work. Conpot, our industrial control system, SCADA, it defaults to, I believe, a Siemens PLA device. And again, much like Dionaea, it actually uses the same shellcode emulation. It has full shellcode emulation abilities. One of the key differences is that it provides a web server, SNMP, Modbus. It does provide a couple other options if you configure them. But otherwise, that's about what it does by default. And this is specifically for your building control systems, your temperature stuff, nearly anything that runs a building and other physical things. So they're rather important, and they're rather not secure, which is not a good thing for what they do. Iran knows pretty well about that one. I did not have an attack for that because there really is not a whole lot of active attacks that I know how to use against it. So I apologize for not being able to research that one a little better, but it does provide some very interesting things, especially through the SNMP and Modbus daemons that it provides. So in conclusion, Docker is pretty awesome. It does some really useful stuff. As you get into, say, RHEL and Cent7, you're going to be almost forced into using it. It's great. It really makes separating and isolating environments and applications really nice and clean, and you should look at it. Honeypots and the Honeynet Project are awesome. They provide a service that very few people in the world do or could, and they don't get much recognition for it. It's too bad because it's just not a huge industry, and it's not a huge profit-making industry. And of course, Nagios. Everyone here loves Nagios. It's the magic that makes everything happen for this, aside, as far as actually analyzing your data and figuring out where stuff's going on. And compared to dealing with the flat files that these guys generate, This is much better. Those are the locations you can find my GitHub repository with all the code. If you choose to build it on your own, you can steal my Docker files and go for it. Otherwise, if you just want the Docker containers, you can go to docker.com and pull them off there. Like I said, it's just like Git or JIT, however you prefer to pronounce it. And it's just a pull. It's pretty great. We have any questions? Did I scare you all too much? Come on. I don't bite.
So you've got Dockers of the of XI and Log Manager and everything and NNA running inside there. If we are already licensed for production use of those,
I can't comment on that.
okay.
As far as purely licensing goes, it's not changing anything from the way our licensing model goes now. How you choose to use that against what available licenses you have, we can talk about it, but I don't know if we'll make any allowances that are different from normal. But they are really nice to see how we're using resources in our different products. It's actually been very informative.
I have a question about the SCADA
Sure.
detection. So you said it was emulating a Siemens.
I believe that's the case.
Do you know if it can emulate other?
Yes,
systems?
absolutely. It's actually got a, the way Conpot is configured is it uses basically XML templates. And you can specify new protocols to add there and give it, it's a mixture of XML templates, scripts, and files that you want it to host. So like the web application stuff, if you wanted to host another web app on, say, 443, say your device emulates that. You could do that. You just have to put the files there. You have to change the template for it, and it'll pick it right back up on the next reboot. If you want to add custom, say, protocols or something like that, or a different way it interacts and responds with the same protocol that's already built in, as far as I understand, I didn't write it, but as far as I understand, it should be able to do all of that. They've very intentionally made it highly customizable so that you can emulate your systems as closely as possible.
Just one other question in relation to that. Would you recommend only have it emulate your systems, or would you recommend have it emulate a different system? So we don't use Siemens, but if we had to emulate systems, would the attacker believe that we had Siemens and then try and focus on known exploits for Siemens?
That's a very good question. To be totally honest, it's a personal preference thing. If you're an environment that only runs one type of SCADA system, I would probably try and emulate that system and make it as realistic as possible. Why should it be the one needle in the haystack? But at the same time, that might provide an interesting perspective to see if, hey, you did get someone in there, or when your pen testers see it, how do they react differently to it? So I could see it going both ways. It really depends on what you want to do. Oh boy.
How's it going, Spencer? So I had a question on the note of Log Server.
Sure.
It was a little bit difficult to see it, so I'm just going to ask you. So the Docker containers that you were using, are they just gathering sort of standard system and access logs? And what were you actually looking for on Log Server for the specific strings?
Sure. No. The logs from the honeypots are very, very, very specific to what they do. Let's see if I can go back. I'm not sure how clear Dionaea was, but that's probably the best example. Oh, we're too far back now. Here we go. So once I ran that, if we can see this, okay, it's not a great screen, but effectively you're getting Python debug output, among other things. In this particular screen, no, there is not shellcode in here. No, I've got a set of grok filters that basically, as it comes in, it tags it for specific types, and as it tags, well, initially it's tagged by the sending application for saying, hey, this is a Dionaea log. When that comes in, it starts a set of filters with if statements that, as we go through line by line, I'm filtering out and saying, okay, this one starts with payload. I know that the next string should be shellcode. I want to take that and separate it out into a separate chunk. And that way in Log Server, I can go and filter out, hey, I want this chunk. Or maybe later on, I don't know if we have this functionality or not, maybe I can make it do different checksums against it and compare those against samples that I've found already. But I've gone through and set up a fair amount of filters in there to actually make it separated out. It's just not hugely displayed here. Did that answer everything you wanted?
Any additional questions?
Not a question, but rather a clarification.
Sure.
So these events that you see here is what you consider attacks, and you send it via SNA to Nagios?
I send it, yeah. What's happening here is I'm not, well, there is an agent, but just because something came into your honeypot doesn't mean it's an attack. It may be iTunes trying to scan your network for other iTunes applications, which is perfectly normal and a little strange the first time you see it. And your honeypot would very possibly pick that up because they hit standard protocols. But it is possible that what you're seeing in something like this is an attack. And I want to make sure to differentiate that, because you don't want to be if you were to deploy something like this, you have to understand that yes, you're going to see true positives, but until I really iron out some of this stuff, you're going to see a lot of false positives too. You're going to see a lot of, hey, my iTunes came and did scan my network and Dionaea said something was wrong. Is it really an attack? No. But is it something that maybe you would have wanted to look into the first time you saw it? Absolutely. And so should you treat it like something might have happened? Yes. Should you go, hey, this is the worst thing ever? No. But effectively what these do is they write to another container and write all their log files and all of their storage that they do, whether it's shellcode or attacks that people have sent them. And when they write that out, I have a separate container that is a log server sending container, and that actually sends the logs over to my log server for me to look at. Is that what you were looking for?
Yeah, so basically what you're saying is that your log server does the intelligence part, let's say, of identifying if it's maybe an attack,
Yeah.
and then you send that over to Nagios.
Yes, yeah, and actually that's very true. I do not use XI in the sense of having XI check if there's an attack. XI is what does end up notifying me, but log server is actually what checks the logs, because that's really the most viable option in this particular case. Most of the honeypots don't say send SNMP traps or anything like that. There are some other protocols that I've been meaning to work out that I can deal with on a more real-time basis. But yes, log server is essentially the intelligent brain behind this. It works with all my filters and queries, and I use those to alert passively into Nagios. And that's how I would get a notification to say, hey, here's what's going on. Yeah.
Any additional questions?
So do you have this fully integrated with the other IDS and HID systems? Say we had OSSEC fully rolled out as well as Snort at the top layer?
Not at this point. Shirikata is an IDS derivative of Snort. If you're not aware, it's actually really just a threaded variety of it. It works with everything Snort does. So there is an intrusion detection system, but it's not, say, OSSEC. I don't have other integration with it at the moment. It's pretty isolated to itself. I'd love to hear ideas on thoughts to do stuff, though.
Sure.
Any other questions? Anybody want to try to stump him with a really hard question?
Yeah,
No?
come on.
Oh, we got one in the back. There we go.
For the poodle vulnerability? There's a poodle vulnerability now.
Did you check it this morning? It just came out.
No, I didn't.
Well, you're talking.
Oh, wow.
All right, ladies and gentlemen, how about a nice another big round of applause one more time for Spenser Reinhardt.